Welcome to Sarath C Aviation and Rail Knowledge channel. I am Sarath C, and I extend a warm welcome to you on the Sarath C Aviation and Rail Knowledge channel. Broadcasting from near Pulipura Vainashala, Pangodu, Kallara, Nedumingada, Thiruvananthapuram in Kerala, Bharat, your support through likes, shares, and follows is invaluable. Today, we will explore an engaging topic, the evolution of brake technology in Indian Railways, focusing on the systems used in the past compared to modern technologies. We will also discuss the technological working principles behind these systems, incorporating insights from various sources, including Wikipedia. Historical overview of brake technology in Indian Railways. The development of brake technology has been crucial for ensuring safety and efficiency in train operations. Historically, braking systems have undergone a significant transformation, moving from rudimentary manual methods to advanced automated technologies. 1. Old-time brake technology. Manual hand brakes. In the early days of rail transport, trains relied heavily on manual hand brakes operated by crew members. These brakes required considerable physical effort to engage, leading to inconsistent braking performance and effectiveness. Block brakes. Early steam locomotives utilized block brakes made from wood or metal. These brakes worked by creating friction against the wheels, but they had limitations regarding their effectiveness, particularly during wet conditions, which could lead to reduced stopping power. Vacuum brakes. Introduced in the early 20th century, vacuum brakes became more prevalent. This system utilized a vacuum created in a pipe that applied pressure on brake cylinders to slow down the train. While more efficient than manual systems, vacuum brakes still experienced delays in response time and required all train cars to be equipped with the system to function properly. Transition to modern brake technology. As technology advanced, so did the braking systems used in railways, leading to the implementation of more reliable and efficient braking mechanisms. 2. Modern brake technology. Air brakes. The introduction of air brakes revolutionized train stopping capabilities. Air brakes operate using compressed air to apply pressure to brake cylinders, allowing for quicker and more uniform braking across all cars in a train. This system enables the engineer to control braking from the locomotive, significantly improving response times. Electro-pneumatic brakes. This advanced system combines electronic control with pneumatic action, allowing for faster and more precise application of brakes. Electro-pneumatic brakes enhance safety by reducing stopping distances and providing better control during emergency situations. Dynamic braking. Dynamic braking systems utilize the electric traction motors of the train to slow down. By converting kinetic energy into electrical energy, dynamic braking not only reduces reliance on traditional brake components but also enhances overall safety during long descents. Technological working principles. Understanding the working principles behind these braking technologies helps us appreciate their importance in modern rail systems. 1. Air braking system. Operation. Compressed air is stored in reservoirs and released into brake cylinders when the engineer applies the brakes. The pressure pushes brake shoes against the wheels, creating friction that slows the train. Components. Key components include air compressors, brake valves, and brake cylinders. The air compressor generates the necessary pressure, while the brake valve regulates airflow to each car's brake cylinder. 2. Electro-pneumatic braking system. Operation. This system integrates electronic signals to control the release and application of brakes. When the engineer activates the brakes, an electronic signal is sent to the brake valves, allowing for a synchronized and rapid application of brakes across the entire train. Advantages. The electro-pneumatic system allows for more accurate control of braking force, reducing wear and tear on brake components and enhancing passenger comfort. 3. Dynamic braking. Operation. During dynamic braking, the traction motors switch roles and act as generators. As the train slows down, the motors convert kinetic energy into electrical energy, which is then dissipated as heat through resistors or fed back into the power supply. Benefits. This method reduces the mechanical strain on traditional braking systems, prolonging their lifespan and improving overall efficiency, especially on steep gradients. Conclusion. The evolution of brake technology in Indian Railways showcases remarkable advancements in engineering and safety practices. From manual handbrakes to sophisticated air and electro-pneumatic systems, each innovation has contributed to making train travel safer and more efficient. Understanding the technological principles behind these systems is essential for appreciating their role in ensuring the safety of passengers and cargo. Upcoming scientific investigation documentary. Stay tuned for our next scientific investigation documentary, where we will further explore the impact of braking systems on train safety, delve into the integration of modern technology in railway operations, and discuss future innovations on the horizon for rail transport. Thank you for joining us today in this exploration of aviation and rail knowledge. Your support, by liking, sharing, and following, is essential and helps us continue to bring you educational and entertaining content in the future.